Welcome back to Unit 4. Today we're going to be talking about the percent of change, so make sure you've got your calculator with you, and let's go ahead and get started right now. Welcome back. Today we're going to be talking about percent of change. What is percent of change? Percent of change tells you how much an amount has increased or decreased in relation to the original amount. And to do this, we use a formula. Let's go ahead and take a look at that formula right now. So our formula for percent of change, we're going to take our new amount, whatever the new amount is, subtract our old amount, and divide by our old amount, or new minus old divided by old. This is the formula that we will always use to find percent of change. There is no other formula or other way to find percent of change. This is the way that we have to do it. So let's take a look at how it works in a few different type of examples. So here we are with a couple of examples from word problems. So the first one says that Brian's salary in 2013 was $50,000. In 2014, his salary was $52,500. Find the percent of change. So we're going to be using our formula, that's new minus old divided by old. You can see that we've set that up there with those boxes. So now we need to determine which is the new amount, which is the old amount, and that way we can put them in our formula correctly. So it says Brian's salary in 2013 was $50,000, and in 2014 he made $52,500. So the new amount is going to be $52,500 because that's the one that came after. 2014 comes after 2013, so that's our new amount. $52,500, we're going to put that in our first box, which leaves us with $50,000 as his old amount. So we're going to put that in both the boxes to be subtracted and the boxes to be divided. So now we're going to follow our order of operations. We can't just divide right away. We have to do subtraction first. So 52,500 minus 50,000 is going to be 2,500 divided by 50,000. When we divide that, we're going to use our calculator, and when we get that, we're going to get a decimal that is equal to 0.05, but I'm not looking for decimal of change, I'm looking for percent of change. So I have to change that decimal to a percent, and that percent is going to be 5%. Let's look at the one at the bottom now. And this one says in 2013, Carolina's business was worth $200,000. In 2014, the business was worth $202,500. Find the percent of change. So again, I'm looking for the new versus the old, and I've got 2 years here again, 2013 and 2014. 2014 is going to be the new price because that one came next or came after 2013. So I'm going to slide my $202,500 in the new box. 200,000 then therefore is my old amount, so I'm going to slide that into 2 boxes for old. I'm going to start with my subtraction. 2,200 minus 200,000 is going to give me 2,500 divided by 200,000 this time. And when I do that, I divide them in my calculator and I get the decimal 0.0125. But again, I don't want decimal change, I want percent of change. So I'm going to have to make that decimal percent by either multiplying by 100 or moving my decimal 2 places to the right. And when I do that, I end up with 1.25%. Let's take a look at how it works now with problems with tip, tax, discount, and markup. Here are our problems on tip, tax, discount, and markup. Anna is a waitress. The table spends $20 and leaves a total of $23.60. What percentage tip is this? Now, this is a very important problem that a lot of you are going to deal with in your everyday lives. Many of you will be waiters and waitresses, and you need to know what percentage of money you're making. That will help you determine whether you should stay at that restaurant where you're making good tips or whether you should move to another restaurant where you could receive higher percentage of tips. So to determine our new amount versus our old amount, we have to see that the new amount is $23.60 because that's being added to the original amount. So that's the amount that's changed, so that's our new amount. So let's slide our $23.60 into our new amount. That leaves our old amount to be $20. Fill that in both slots there. Then we're going to do some subtraction. $23.60 minus $20 is going to give us $3.60. Divide that by our $20. When we do that in our calculator, we're going to get our decimal. Our decimal is going to be 0.18. Then I need to make that a percent because, again, I don't want decimal change. I want percent of change. So I'm going to either move my decimal 2 places to the right or I'm going to multiply by 100. And when I do that, I'm going to get 18%. Now, Jimmy goes shopping for shoes. The shoes were originally $75, but they're on sale for $30. What percent of discount is this? So now I've got to figure out which one is the new price here. Well, if they were originally $75, that indicates to me that that is the old amount because that's the original amount. The sale price is $30, so that's my new amount. So I'm going to put that in new in the formula, $30. And that leaves my old amount as 75. So now I need to do some subtraction. 30 minus 75 is going to give me negative 45, or negative 45 divided by 75. I'm going to type that in my calculator, and I'm going to get a decimal, and that decimal is negative 0.06. So now I need to move my decimal 2 places to the right, or I need to multiply by 100, and I do that, I get negative 6%. But often when you go to the store, you don't see something on negative 30% off or negative 20% off. They just tell you that it's 6% off or 30% off or 50% off. So it's very important that when you're talking about percent of change and your percent of change is negative, that means that the amount has gone down from the original amount, you can either indicate that one of two ways. You either have to show a negative sign, which is not very common, or you have to say something like, or a decrease of 6%. Now notice I don't have my negative sign there, but using the word decrease lets you know that the amount has gone down. So when you're using percent of change and your answer turns out to be negative, you need to indicate that there has been a change that has gone down. And you can do that either by using the negative sign or by using words such as a decrease in 6%. So now let's go ahead and take a look at some tables. So here we are using tables to find percent of change. Our first problem says, what is the percent of change from February to March? Round to the nearest percent. So first I need to take a look at my table and find the information. I could see some February that my price is $34. I could see my price in March is $70. So I'm going to have to write that information down. I've got to figure out which one is the new. So to figure out which one is the new, I can just take a look at my calendar, realize that March comes after February, so therefore that price is going to be the new price. So my new price is going to be $70. That leaves my old price to be $34. So I'm going to subtract 70 from 34 and make sure that I'm dividing by 34. 70 minus 34 is going to give me 36. So I have 36 divided by 34. I'm going to go ahead and type that in my calculator. When I type that in my calculator, I'm going to get the decimal 1.058, and then it goes on and on forever without repeating. Now I need to take my percent or my decimal and make it a percent. By doing that, I'm going to either multiply by 100 or move my decimal 2 places to the right. I'm going to be moving my decimal 2 places to the right. When I do that, I should get 105. However, I need to make sure that I'm rounding properly as the problem tells me. So I'm going to take a look at that 8, and that 8 is going to indicate to me that that 5 needs to go up rather than staying the same. So my answer should be 106%. Now, how can you have over 100%? Well, when you're talking about a percent of change, if something were to do more than double, if the amount was to go over double the percent, then that would be where you would get 100%. So the amount of money, the $34, has gone up by over $34 because it's gone up 100% plus in this case. It's gone up 106%. So that is how you have over 100% when you're talking about percent of change. Now our second question there asks, what is the percent of change from April to May? So again, I have to look at my table. I've got April at $115 and May at $86. So I know, again, I got to figure out new versus old. May comes after April in the calendar, so I know that is the new amount. So I've got $86 there. Then I'm going to be subtracting the $115 that is my new amount and dividing by, or my old amount, and then dividing by 115, which is my old amount. When I do that, I should get negative 29 divided by 115, and then when I divide negative 29 by 115, I get the decimal that is negative 0.252, and then it goes on and on forever and ever without repeating. So now again, I have to take my decimal, make it a percent, because I want percent of change, not decimal of change. So I'm going to move my decimal 2 places to the right, or multiply by 100. In this case, I'm going to move 2 places to the right. And when I do that, I get 0.25, but then I have to make sure that I'm rounding properly. So I'm going to go ahead and take a look at that 2. That 2 is not going to cause that 5 to go up, so that means that my final answer is going to be 25% negative. Now, again, I can use the negative to show that I know the amount is going down, or I could write to a decrease of 25%. Either way is correct, but I have to make sure that I'm indicating to people when I put my answer down that I know that my answer is a negative answer, or that the percent of change has turned out negatively. Let's go ahead and take a look at some more tables. So here we are at our tables, and it looks like we've got our train table again, except we've got a couple of months there that haven't been filled in, and it's asking us to fill them in. So let's take a look here. It says from June to July, the cost of the train ticket increased by 20%. So this time I don't have to find the percent of change. It told me the percent of change. The percent of change is 20%. So I have to figure out what that amount is so I can figure out how much it's gone up by. So in this case, I know that June is $115, and I'm going to be figuring out that that's a 20% increase. So to figure out what 20% increase of 115 is, I need to think way back to the beginning of the year and figure out how I show a percentage of an amount. And to do that, I'm going to multiply. I'm going to multiply my $115 by 0.2, or times my decimal, and 0.20, because I can't put 20% in my calculator. I had to make it a decimal. So $115 times 0.2 is going to give me $23. So is the cost of the ticket $23? No, that's not the cost of the ticket. It didn't go from $115 to $23 because we already know that it increased. So since it said it increased the price, I know 23 can't be my stopping point. So what $23 is how much it went up by. So $115, when you increase that by 20%, that's a $23 increase on the price ticket. So now I have to figure out the price of the ticket. To do that, I'm going to take my $115 plus the $23 that is my increase, and I'm going to get $138. So that is the new cost of the ticket. Let's take a look at the second problem. The second problem says from July to August, the train ticket increased another 20%. So they must be really trying to increase the prices in the summer because they know that's when lots of people are traveling because there is no school. So I've got to figure out from July to August. So luckily I just figured out July is $138, and I figured out how to multiply by the decimal to figure out the percentage of $138. So I'm going to be taking $138 times 0.2, because again, my percentage needs to be a decimal, and in this case 20%, the decimal is 0.2. When I multiply those together, I get $27.60. But again, that's not my final stopping point. That just tells me how much more money the ticket is going to cost me. So I'm going to have to add those together. $138 plus my $27.06 or 60 cents is going to be $165.60. So those are my final answers. Now I just need to make sure that I fill in my chart. So I've got $138 for July and $165.60 for August. Now let's take a look at a different kind of table. So here we are at another type of table, and this table appears to be a bar graph. It says the number of students who purchase lunch in the cafeteria. So we have a couple problems to do. The first one says, what is the percent of change from Wednesday to Thursday? So in order to figure out what Wednesday and Thursday are, we have to take a look at our graph. So I'm taking a look at Wednesday, and it looks like Wednesday, the number of students is at 900. And I have to take a look at Thursday, and it looks like my students there are at 100. So now that I know the two amounts, I have to figure out which one is the new and which one is the old. Well, since Thursday comes after Wednesday in the days of the week, I know Thursday is going to be my new. So I'm going to set up my problem. I'm going to have 100 as my new amount. I know that 900 is going to be my old amount, so I'm going to go ahead and drag that one in. Then I need to divide by 900, so I'm going to bring down my division and bring over my 900. I'm not going to solve that problem just yet, but I've got it set up. Let's take a look at the next problem. The next one says, what is the percentage of change from Thursday to Friday, round to the nearest percent? Well, luckily, I've already figured out what Thursday is. I know that's 100, so now I just have to figure out what Friday is. When I take a look at my graph, I can figure out that Friday is 350. So now I just have to set up my problem correctly. I got to figure out which one is the new, which one is the old. Since Friday comes after Thursday, I know that's going to be my new amount. So I've got my 350. Then I'm going to subtract from that my old amount, and in this case, it's going to be Thursday at 100. And then I'm going to be dividing by 100 because that is my old amount. So now I've got both problems set up. I want you to go through and finish the problems to see if you can get them correct. We've done percent of change a few times now, so you're just going to be subtracting your calculator and then figuring out how to take that decimal to percent. So I want you to pause the video now, do these two problems on your own, and then press play again to see if you are right. How did you do? Were you able to get the same answers that I got? Make sure that you checked your rounding in the first problem so that you got 89%. And in the second problem, you should have gotten 250%. So it looks like that whatever the Wednesday meal is very popular, and the Thursday meal not so much. And then there's a little bit of recovery on Friday. So let's go ahead and take a look at the last one. So the last problem we have says, since 2010, each year the population of Lake Forest neighborhood has decreased 25% from the previous year. Show this on the graph provided. So they gave us 2010. We need to figure out 2011, 2012, and 2013. So again, this time they gave us the percent of decrease, and we've got to figure out how much it's gone down by and then fill in what is the amount. So I know that I have 8,000 to start, and I know that I have 25% for my problem as the percent of decrease. So I'm going to be multiplying my 8,000 times my 25%, but again, I can't multiply by 25%. That's got to be a decimal, so I'm going to do 8,000 times 0.25, and when I do that, I get 2,000. Now, did the population drop straight from 8,000 to 2,000? Absolutely not. That's just how much a 25% decrease is from 8,000. So now I have to subtract, because it's talking about a decrease, to 2,000 from 8,000. And when I do that, 8,000 minus 2,000 is 6,000. So now I need to show that on my graph by shading in 2011 up to the 6,000 mark, which indicates the new population for that year. Now, I want you to take the information that we just have, and I want you to do 2012 and 2013 for yourself. So you're going to go ahead and pause the video, try those two on your own, and then press play again to see if you are right. How did you do? Were you able to make your graph look like mine? Did you figure out that 2012 was 4,500 and that 2013 was 3,375? If you did, great. If not, go ahead and correct your paper so that it looks like mine. That brings us to the end of these set of notes. So if you like this video, go ahead and throw us a thumbs up. If you love this video, go ahead and throw us a sub, and we will catch you in the next one.